He knows a lot about the science stuff. Professor Dave explains.
Okay, let's try a problem regarding equilibrium constants. So consider the following reaction. SO2 gas plus NO2 gas yields SO3 gas plus NO gas. And the question asks, at a particular temperature, this has an equilibrium constant of 16. If we put 1 mole of each of these 4 gases in a 1-liter container, what will be the equilibrium concentrations of both NO2 and NO? So if you need some review, check out some of my tutorials regarding equilibria, and when you're ready, give this a shot. So first, let's write the equilibrium expression. So we know that Kc is going to be equal to the concentration of SO3 times the concentration of NO, because those are gaseous products, over the concentration of SO2 times the concentration of NO2, because those are the gaseous reactants. And we also know that that equilibrium constant is equal to 16. Now, the fact that that is 16, meaning it is greater than 1, tells us something about where the equilibrium lies. It lies towards products, right? So if it's greater than 1, we're going to have more products than reactants at equilibrium. And so that's important because we have to know which way this is going to shift. If we put 1 mole of each gas in the container, is this going to go to the right? Or is it going to go to the left? And because the equilibrium constant is 16, we know that it is going to go to the right. There's going to be more products than reactants at equilibrium. So what this means is that we can do some algebra here. Let's say that the equilibrium constant, 16, equals 1 plus x times 1 plus x, because SO3 and NO are starting at 1. We'll say we've got 1 mole, plus x, some amount, right? We know that we're going to be forming some more of the products because the equilibrium will shift right after we put a mole of each gas in the container. That also means that SO2 and NO2 will become 1 minus x because some amount of those will be used up to form the products. So that is our new algebraic equilibrium expression. And so we can now simplify this by writing 1 plus x squared over 1 minus x squared. So if we have 16 on the left and then these two squared terms on the right, we have perfect squares everywhere. Let's just go ahead and take the square root of both sides. So 16 becomes 4, and then on the right, we just lose those exponents. So now 4 equals 1 plus x over 1 minus x. If we multiply both sides by 1 minus x and then simplify, we get 4 minus 4x equals 1 plus x. Simplifying further, 5x equals 3, and then x equals 3/5 or 0.6. And so because we know we have a 1-liter container, we started with 1 mole per liter, 1 molar, and each of the reactants is going to lose 0.6 moles, and each of the products is going to gain 0.6 moles. And so that means that if we have 0.4 moles of each reactant, like NO2, that is going to be 0.4 molar. And if we have 1.6 moles of each product, like NO, we're going to have a 1.6 molar concentration of NO. And so that's a little bit of algebra regarding equilibria.
Thanks for watching, guys. Subscribe to my channel for more tutorials. Support me on Patreon so I can keep making content. And as always, feel free to email me, ProfessorDaveExplains@gmail.com.